Good day, everyone. Today, we are talking about number systems and binary computation. What is number system? Number systems are fundamental to how we represent and manipulate quantities. While we commonly use the decimal system in our daily lives, computers rely on a different system like binary. Binary conversions, decimal to binary. Converting a decimal number to binary involves repeatedly dividing the decimal number by 2 and recording the remainders. The binary representation is then formed by reading the remainders from bottom to top. First, we need to divide it by 2. Divide the decimal numbers by 2. Then, we record the remainder, or we should note down the remainder. It's either 0 or 1. Next, number 3, repeat. Continue dividing the quotient by 2 until it becomes 0. And then last but not the least, read it upwards. The binary number is a sequence of remainders read from last to first. Example of decimal to binary conversion. Let's convert the decimal number 13 to binary. We have here number 13. What do we do first? Yes, we should divide it by 2. So 13 divided by 2 is equal to 6, and the remainder is 1. Then next, 6 divided by 2 is equals to 3. Remainder is 0. Then 3 divided by 2 is equals to 1. So its remainder is 1. 1 divided by 2 is equals to 0. Always remember that when it becomes 0, it should be 1. We have binary conversion. Binary to decimal. To convert a binary number to decimal, each binary digit or bit is multiplied by 2 raised to the power of its position, starting from 0 on the rightmost side, and the results are then summed up. We have 2 steps. First, we have identify positions. Assign powers of 2 to each bit starting from 2 raised to 0 for the rightmost bit, and then we multiply and sum. First, we multiply each bit by its corresponding power of 2 and add products. Here is our example of binary to decimal conversion. 1 times 2 raised to 3 plus 1 times 2 raised to 2 plus 0 times 2 raised to 1 and 1 plus 1 times 2 raised to 0. Then next is 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 4. Then we will multiply first 8 plus 4 plus 0 plus 8. Then we add all, it will become 13. So 1101 is the decimal representation of 3. Addition using addition. Binary addition follows similar rules to decimal addition, but with only 2 digits, 0 and 1. When the sum of 2 bits is 2, a carry over 1 is generated, the next position and the current position becomes 0. There are 4 steps. When 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1. However, if it is 1 plus 1, it will be 0 or 1. Example of binary addition, let's add 2 binary numbers, 1011, that is the decimal for 11, and 0110, decimal for 6. Let's add 1011 plus 0110 is equal to 10001. The result of the binary addition is 10001, which is decimal 17. We have binary computation using subtraction. Binary subtraction can be performed using the borrow method. Similar to decimal subtraction, or by using 2 complement for negative numbers, we will focus on the direct subtraction method here. So, we have 2 steps. First, we should align numbers. Place the subtrahend below the minuend, aligning the bits. Subtract bit by bit. Subtract each bit, borrowing them from the left if necessary. 10 minus 1 is equal to 1. Example for binary subtraction. Let's subtract 001, that is the decimal for 3, from 1010, that is the decimal for 10. So, 1010 minus 001 is equal to 0111. The result of the binary subtraction is 0111, which is decimal to 7. This is binary computation using multiplication. Binary multiplication is a conceptually similar to decimal multiplication, involving a series of shifts and additions. Each bit of the multiplier is multiplied by multiplicand, and the resulting partial products are then summed. There are 3 steps. First, multiply by bit. Multiply the multiplicand by each bit of multiplier, 0 or 1. Second, shift products. Shift each subsequent partial product 1 position to the left. And third, summation. Add all the shifted partial products together using binary addition rules. Let's multiply 2 binary numbers, 101, that is the decimal for 5, by 011, decimal for 3. So, 101 is the multiplicand, while the 011 is the multiplier. 101 times 001 is equal to 01111. Binary computation using division. Binary division is performed much like long division in the decimal system, using repeated subtraction and shifts. It's a fundamental operation for computers to divide numbers using their native binary arithmetic. There are 4 steps to follow. First, we need to compare. Compare the divisor with the leftmost of the dividend. Second, quotient bit. If the divisor can be subtracted, place a 1 in the quotient. Otherwise, place 0. Third, subtract and remainder. Subtract the divisor if 1 was placed, and note the remainder. Last but not the least, bring down and repeat. Bring down the next bit of the dividend and continue the process until a bits are used. Tool of binary division. Let's divide the binary number 1010 decimal by 10. By 010, the decimal for 2. So 010 is the quotient and 1010 is the dividend. Let's see. When 1010 divided by 010, there is no remainder, so it will be 0. The remainder will be 0. So the result of the binary division is 101, which is the decimal of 5.